Hi, this is Paul. I'd like to talk about a couple of patches I just recently designed for usage with the Osmose MPE keyboard, and they could also be techniques that could be used for other MPE controllers. And we're just going to have a quick walkthrough of the patch design for these two patches. So let's start by taking a look at the MPE cello combi and the Expressive cello layer. The notes input node for this patch is set to 16 voices because that's the number of voices on the Osmose by default. MPE mode checkbox is enabled, and in this version of the patch I actually left the AT to MW checkbox enabled. This allows the aftertouch to actually get forwarded to the mod wheel output, because in this patch originally the mod wheel was already connected to lots of different things, so it's actually easier just to leave it connected and allow the aftertouch messages to get propagated to the mod wheel. So you can see here I'm just highlighting that the aftertouch has no connections. As soon as you connect something to the aftertouch pin in Hyperion, the AT to MW functionality is cancelled. Here you can see the mod wheel is connected to the LFO level, which is in turn modulating the filter depending on the aftertouch pressure. The envelope's attack time are modulated by velocity, and it's a negative modulation, so the harder you hit the key, the faster the attack, as can be seen on the envelope display in the edit panels. For the other layers, I've enabled MPE mode and made sure they all have 16 voices enabled, but on most of them I've disabled the AT to MW feature because I don't want the aftertouch to affect the mod wheel outputs of those layers. Also, as you can see, I've disabled the pitch bend and mod wheel input anyway into those layers, so that I won't affect the sound of those layers as I play the MPE controller. At least I won't affect the modulation of those layers. In this particular combi, all the layers are just stacked in the same key and velocity zones as the cello patch. Let's take a look at the Overblower patch. This is a flute simulation using multiple elements to represent different parts of the flute sound. In this combi I've split some of the sounds to the left hand side of the keyboard and kept the flute in the right hand side of the keyboard, or the upper side. You can see in this patch I've connected the value viewing graphs to the MPE Y aftertouch and the mod wheel, if you get the mod wheel output, so we can see what's going on with the modulations. Just gonna disable the other layers in a minute, but first of all just pointing out that these layers have the pitch bend and mod wheel inputs disabled in most cases, and they are set to MPE mode, each with 16 voices, and AT to MW is disabled in these patches. Let's just mute these layers. And AT to MW is also disabled in this Overblow patch because I'm actually using the aftertouch pin directly in this case. Let's take a look at how this sound is constructed. The first element here is a series of tones with different pitches which increase, the wave sequence position increases depending on the pressure. in the aftertouch axis, which simulates what happens if you overblow a pipe. You get these extra overtones or harmonics. You can see also that the ring mod is being affected by the aftertouch pressure. The Y pin is also connected to various things, including filter cutoff. And here you can see the aftertouch is controlling ADSR2 level, which is actually connected to the filter cutoff as well. This is the second element, is a overblown sound. It's just a sine wave going into a comb filter. The comb filter saturation level is being increased, again with pressure, as is the feedback amount, and this leads to the rough sound that you hear. All of these sound sources are going through the tube resonator. All of these sounds are going through the tube resonator, and there's a filter at the end of the chain which is blending between low pass and high pass depending on the pressure again. This is a more pure sine tone, which just represents the sort of the root of the sound. Its level is also modulated by the aftertouch control. And you can see the ring mod depth is also controlled by pressure. And finally we have noise, which simulates breath sound, and the amount of noise is dependent on the velocity, and there's a separate envelope just for the noise pulse. And depending on how hard you play, that has a bigger or smaller effect. Actually it's a negative effect based on the velocity, so that the amount of that envelope is reduced, but at the same time the y-axis of the MPE controller modulates the shape of that noise, which is internally it's a low-pass filter in the noise oscillator. It's a pretty subtle effect, but it's part of the sound that, you know, if you add these multiple elements together, you end up with a pretty convincing flute sound. The aftertouch is also controlling the amount of vibrato and the amount of the vibrato speed. So I'm talking about aftertouch here, but this is actually mapped to the aftertouch parameter of the Osmose. By default, the aftertouch parameter of the Osmose sends out CC74, but I've changed the settings on my Osmose to send out channel aftertouch for the aftertouch action, and for that initial key strike and vertical position, it's actually controlling the y-axis, which is CC74. And here are the sounds together again. In both of these patches I've set the bend ranges to the maximum. In fact, that's the default when you turn on MPE mode. But if you want to do if you want to do pitch bends with a pitch bend stick, that range is quite a lot, and it might be good to turn down the range in Hyperion and then also turn down the output range for the key bending. I'm going to be sharing these patches on my Discord, and there's a link to the Discord in the video, so come and join us and you can have access to these two patches and their associated combis. Yeah, thanks for watching.